Hi everyone, I am Mr. S. Vanchinathan from the Physics Department, K.S.Rangasamy College of Technology, Tiruchengood. Today we will start Module 1 of Engineering Physics, Crystal Physics. In this session, we will understand how solids are classified, what crystals are, the concept of unit cell, and different crystal system. And then today we can discuss introduction of crystallography, the difference between crystalline and non-crystalline solids, understanding the unit cell concept, and learning about the seven crystal system. Introduction to crystallography. Crystallography is the branch of science that studies the internal arrangement of atoms in solids. It explains the different types of crystals, how we determine the crystal structures using X-rays, electron beam, or neutron diffraction. The interatomic arrangements inside a crystal, the bending between atoms, and how it relates to the strength of materials. Classifications of solid. Solids can be classified as crystalline solids and non-crystalline solids or amorphous. Crystalline solids, they have a regular periodic arrangements in three dimension. Example, Na crystal and diamond. And then crystalline solids are further divided into single crystals and polycrystals. Single crystals is nothing but the whole specimen is one continuous crystal with atom arranged uniformly. Polycrystal is nothing but made of many small grains or crystals, each with its own orientation. And then amorphous or non-crystalline solid is nothing but atoms are arranged irregularly and do not show periodically. Examples glass, rubber, plastics. The single crystals versus polycrystals. In a single crystal, the periodic arrangements are terms extend throughout the whole volume. So polycrystals, the arrangements is regular only within each grains. The grains are separated by boundaries with different orientation. So crystalline and non-crystallines, the difference. Let us compare the two crystalline solids and amorphous solids. The crystalline solids, regular arrangements of particles, soft melting points, and characteristics heat of fusion. They are anisotropic. Non-crystalline solids have random arrangements of particles, no short melting point, and they are isotropic. And examples of crystals, here we see natural crystal examples: diamond, graphite, quartz. And then unit cell. A unit cell is the smallest three-dimensional geometrical figure, the repetition of which builds the entire crystal. It contains complete information about the arrangement of atoms. By stocking unit cell face to face in all directions, we reproduce the whole crystal structure. Unit cell in three-dimensional. This slide shows how a unit cell looks in three dimension. The unit cell is defined as the three edge lengths and three interaxial angles, and these parameters describe the geometry of crystal lattice. This is the schematic diagram of unit cell in three dimensional. And then seven crystal system. Crystals are divided into seven based on the edge length and angles. The first one is cubic, and then second one is tetragonal, and third one is orthorhombic, and fourth one is trigonal, and fifth one is hexagonal, and sixth one is monoclinic, and seventh one is triclinic. Each system represents a family of shapes determined by symmetry. And then Bravia's lattice in the seven crystal system. The apart from the seven systems, we classify lattice by how atoms are arranged inside the cell. And then primitive cell, body centered, face centered, and base centered. Primitive cell atoms only at the corners. Body centered is the atom at the center, one atom at the center, and face centered atoms is nothing but one atom at the center of each faces. Base center is the atoms at the centers of two opposite faces. These combinations with the seven crystal systems give us the 14 Bravia lattice. The cubic crystal systems example: simple cubic, atoms at corners only. Example, polonium. Body centered cubic, atoms at corner plus 1 at the center. Example, iron and chromium. Face centered cubic, atoms at corners and centers of faces. Example, copper, aluminum and gold. These structure influence density, sleep plans and mechanical behavior. These 14 ways of arrangements in the periodic manner of seven crystal system is called Bravia's lattice. And then today, the model 1 concluded the crystal physics. We discussed how solids are classified, the concept of unit cell, crystal system, and Bravia's lattice. In the next class, we will move on the imperfection in crystals and their effect on material properties. Thank you to all.